Day 15. We're still setting up these equations and defining functions. This could be very challenging. It's okay. We're going to do it together. I'm going to do 3 more examples today, and we'll do plenty more in class. So first one is example 9. Yes, we're jumping around, keeping it simple. So 800 feet of fencing is available to enclose a rectangle pasture for a farmer's alpacas. The pasture is alongside a river, as shown, which serves as one side of the rectangle. So really, you only need 3 sides for the fencing. Express the area as a function of x. Okay, so here's my goal. Area, which is normally length times width. I guess I'll call it length times x, right? That's my width. I now want this only in terms of x. So somehow I have to get rid of L. Okay, well, let's see. If that's x, this is x. This will be my length. And I'm given 800 feet. So really, my perimeter is 800 feet. So if I have 2x plus L will equal my 800 feet of available fencing. Right, 2L plus L. I don't need this L over here because that's the water. I guess alpacas are scared of water, hopefully. If I can get L by itself, plug it in, I'll get everything I want. So here we go. 800 minus 2x. I can take that now, plug it into what I want to then get area just in terms of my variable x. Let's distribute. I would get negative 2x squared plus 800x. Okay. Example 10. The volume of a right circular cylinder is numerically 3 times the surface area. Find first the height as a function of radius, and then 2, the radius as a function of height. So we're kind of flip-flopping what we're finding. First thing I care about is that it mentioned surface area and volume. Go back to that beginning of day 14 notes with all those formulas. Use it. Okay, we know that the volume is going to be pi r squared h, and surface area is 2 pi r squared plus 2 pi r h. Okay, good to have those written down. The first one wants us to find height as a function of radius using that it's 3 times, the volume is 3 times the surface. Okay, let's see. So part 1, let's take it step by step. It's saying that the volume is 3 times the surface area. That's what I'm given. Let me substitute in those formulas. Oops. 3 times it, so I'm actually going to do the multiplication as I go. So it would become 6 pi r squared plus 6 pi rh. Now I want h as a function of r. That means h equals something with r. Okay, that's what I'm trying to find. So I want to get h by itself, which means I'm going to put h to the same side. All terms with h are actually going to go on the left side. So I have pi r squared h minus 6 pi rh going to equal 6 pi r squared. I'm close to getting h by itself. On the left side, I can take it out as a GCF. And then how do you undo this multiplication? Well, with division. So h is going to equal 6 pi r squared over pi r squared minus 6 pi r. Okay, realize there is some things you can cancel from every single term. Notice the pi's can go away from all 3 terms. Notice the r can go away. This r, one of those r's, and one of those r's. So my final answer of height in terms of radius would look like so. Okay, height in terms of radius. That is part 1. Part 2 now wants us to do the same thing, but now have radius equal my height. So I'm going to take this beginning part, because it's going to be the exact same. But now I'm just solving for a different variable. Okay, I want to get r by itself. So that means I'm going to put all my r terms together. So I'm going to go pi r squared h minus 6 pi r h. Oh, actually, easier way, my dears. Oh, look at me, right? You totally can do that. It'll take a little bit of time. But realize, for part 2, oh, look at that. I can just take this problem. H equals 6r over r minus 6. Oh, you guys are probably like, yes, so much easier. Okay, I just want to solve for r. I'm going to put this over 1. Let's do a little cross multiplication action. Make sure you distribute the h to both terms. Let's get our r terms together. Factor out that r with my GCF that I love. Divide, and I would get negative 6h over 6 minus h. That is radius in terms of height. Okay, so always try to find the easiest way. You could do it the long way like I was starting, but let's make our lives easy. Number 11. A line is drawn from the origin O to the point xy on the first quadrant on the graph of y equals 1 over x. Okay, I'm going to start a picture. We should know what that graph's going to look like. Right, we've done this before. It's going to look like this. We're just talking about the first quadrant, so we only care about that one. On the graph, from point P, a line perpendicular to the x-axis meeting the x-axis at B. So that means down here, this will be perpendicular, which means 90 degrees at point B. Origin is 0, 0. And here creates my triangle. Draw the diagram, and let's write the area of a triangle as a function of x. Okay, so here's PXY. And let's jump into this. My goal is to write area, which is normally base times height or x times y, but only want x, so I need to get rid of y. We did something similar like this yesterday. Okay, well, looking at it, if this is my x and this is my y, we are given in the problem what y equals. Y is 1 over x. So this point is really px 1 over x. I can use that to my benefit. I can use that right in my equation now. It's going to be 1/2 x times 1 over x. Those will cancel. So actually, I don't even need it in terms of x because it goes away. I'll just have 1/2 units squared, whatever it is, because that's area. Probably should have been doing units for all of them. Yep. Units are needed, peeps. So here, this would be feet. And this one will just be units. So yeah, of course. Get through all this and forget units. So don't do it. Okay, remember units so that you don't lose silly points. But this is day 15. We'll practice more in class.